Hi everyone, my name is Sarah Ejaz, and I'll be presenting the paper Interactive Tools for Mnemonics Creation and Knowledge Retention, a scoping review. The authors of this paper are Sarah Ejaz and Kiemute Oyibo. These are the contents of my presentation. Now let's start off with an introduction. In pedagogical settings, courses like biology and psychology are memory intensive, based on the large number of concepts that must be memorized correctly. Due to the difficulty of such courses, students tend to struggle while learning and resort to rote learning to prepare for exams, which prevents them from learning topics in depth. Bonwell and Eison introduced active learning, a way for students to actively participate in their own learning. Research has shown that using mnemonics is an effective method that promotes active learning. Various experiments showed that participants who used mnemonics to learn achieved good performance scores. Interactive tools with the functionality to create mnemonics can help boost active learning and knowledge retention to aid the revision of concepts and self-testing as practice. And before we move on, what are mnemonics? They are memory aids used to ease memorization and recall of information. They have various types, such as acronyms, acrostics, and keyword mnemonics. This is an example of an acrostic mnemonic used to memorize the planets in the solar system. This is an example of an acronym used to memorize the Big Five personality traits. Now on to the research questions that guided the scoping review. Firstly, what pedagogical tools are available for mnemonic creation to promote long-term memory? What are their key features? In what subjects are they commonly used? And how effective are they in promoting long-term memory? Now on to the methodology used. We used a three-stage approach of conducting a scoping review proposed by Tranfield et al. We started off by scoping the literature. Then we did a database search, and we screened the papers based on the title and abstract. Then we did a full text review of the papers. Then we resolved any disagreements that occurred during the screening process. And lastly, we extracted relevant data from the papers and tabulated them. This is the Prisma flowchart that shows our screening process. We started off with 2,037 articles, out of which we removed duplicates, non-English articles, and non-journal and non-conference papers. Then we had 962 articles, which we screened based on title and abstract. Then, after that, we had 32 articles. We did a full text review of those articles and included an article from our Google Scholar search and snowballing method. Finally, we included 9 articles in the scoping review. Now I'll be discussing the results of our scoping review. Firstly, we looked at the target subject of these tools, majority of which were about language learning, followed by learning terminology. Then we looked at whether the tools were user evaluated. We found that only 44% of the tools were evaluated by users. Then we looked at mnemonic generation. We found that 67% of the tools automatically generated mnemonics, while 33% manually generated mnemonics. Then we looked at mnemonic types and found the majority of them used various types of mnemonics, such as stories, phrases, musical, and general mnemonics, followed by keyword mnemonics and acronyms. We also looked at learning evaluation. We found that 37% of the experiments performed testing immediately after the participants learned the concepts. 27% conducted tests 1 week after learning or more, while only 9% conducted a test 24 hours after learning. Now we'll discuss the results of the scoping review. Let's look at some of the available mnemonics creation tools. Some created devices on their own with the option of users to add their own mnemonics, such as Lin et al., who created a portable multimodal kanji learning device. Kanji is a logographic Japanese writing that uses Chinese characters. Some made use of existing tools to incorporate mnemonics into, such as Agnes and Srinivasan, who used a flashcards-based tool called Anki for learning English terms using keyword mnemonics. Some produce algorithms to automatically generate mnemonics, such as Mount Stevens, who used genetic algorithms to generate acronyms for technical lists. There are very few tools that allow mnemonics creation in educational settings. This may be due to the fact that there is a low awareness about the effectiveness of using mnemonics in knowledge retention. Hence, this can provide an opportunity to create such tools that can help engage students in learning material. Now, looking at the key features of mnemonics creation tools. 66.7% of the tools did not have distinctive features besides a learning section where users could create or memorize mnemonics, and a test section to assess if they learned the information. A study done by Huntington et al. Lists important features to be implemented in interactive learning apps, such as feedback and social interaction. Future work should be done to bridge the gap between such studies and the motivation behind implementing certain features in mnemonics creation tools. Now let's look at the subjects in which mnemonics creation tools are used. 55.6% of the tools are about learning a language. Miscellaneously, other tools cover topics such as healthcare terms and technical lists of terms from different subjects. Mnemonics can help in memory-intensive courses, and currently, tools are not aimed at learning concepts from such courses, like biology, psychology, or human-computer interaction. Future work should focus on such subjects to find the effectiveness of interactive tools in promoting long-term memory. Now, discussing the effectiveness of interactive tools in promoting long-term memory. Firstly, in terms of long-term testing, Keel and Meltzer recommended participants to take a test 24 hours after they learned kanji characters. Their experiment showed that participants were able to learn stroke composition of kanji characters with the help of musical mnemonics. Mount Stevens took a test 1 week after the first test and found that mnemonics helped improve the test scores of participants compared to those who used rote learning. Agnes and Srinivasan took a test 21 days after the first part of the experiment. They found that using mnemonics helped increase the participants' test scores and improved their retention of vocabulary. We found that most papers did not focus on longitudinal testing. Rather, they focused on the results of using mnemonics against rote learning. Hence, more studies are required to assess the impact of mnemonics creation tools on long-term memory. Now on to the conclusion. In conclusion, the scoping review discusses the potential of interactive mnemonics creation tools in improving long-term memory in pedagogical settings. Further research is needed to assess the long-term effect of such tools. There's also a need to focus on implementing key features that are personalized based on user preferences. Lastly, users should be allowed to check the fitness of the mnemonics they create or mnemonics generated automatically. These are the references that I used in this presentation. Thank you so much for listening to my presentation.